Here in the Angeli Prodotti we are 500 people, everybody dedicated to the energy transition with our complete portfolio of products. In this attitude we have decided to make a large investment to manufacture insulated copper flat wire for the winding of high-tech motors for electric vehicles. We make internally all the activities of research and development, manufacturing and test with a dedicated laboratory with a lot of very modern instruments.
Here we are in the peak extrusion line. This line is developed for wire where the specification is requested for 800 voltage and for high chemical resistance and compatibility, so for high request. The line permits to produce rectangular shaped wire for the hairpin technology. And for this reason, we start with an inline drawing machine where from a round wire we have a drawing system that permits to create the rectangular shape in accordance with the specification of the customer. So we have a final phase of drawing. After the inline drawing, we have a phase where we clean and also we preheat the wire in order to enhance the adhesion of the peak to the wire. This is an internal phase that we have developed, so for our IP we are not showing it, but it is the key phase during the peak extrusion. After the peak extrusion on the copper wire, we have a cooling phase divided into an air cooling and a water cooling. And it is specifically designed to have the optimal crystallization of the peak because the crystallinity degree of the peak is strictly related to the final thermal properties of the wire. During the peak production, we have also the possibility to control the defects on the wire, and we have two possibilities. The first one is the blister detection that we can detect with these laser instruments. But we have also the possibility to detect the pinhole on the insulation of the wire. And for this reason, we have a spark tester where we can check different voltage in order to satisfy the specific that the customer requires to us. But the same specification can be associated with the monitoring for the blister, where we can change the dimension of the defects.
This is our new line, completely dedicated to automotive sector for project 400 and 800 volts. All start with the semi-finished material, the copper, that can be oxygen-free copper or ETP copper. In this machine behind me, we start to handle the material. So starting from round wire, we produce a flat wire. In this stage, it's very important to produce a very excellent product, semi-finished product, because it's very important to guarantee high quality in adherence and in flexibility in the next stage once we are going to apply the enamel into the flat wire. The product range of the machine in this stage is from 0.8 to 3 mm in thickness and from 2 mm to 6 mm in width. After inline rolling machine, we have the annealing process, a key step to remove the residual stress of the material and to prepare the surface for the enameling application. We finally arrive into the heart of the process when the varnish is applied. We can produce here a dual coat for 400 volts, polyaceramide plus polyamide imide, or a single coat for 800 volts, the polyamide imide solution. A fundamental part is the decision of the enamel with the viscosity and the number of the passages for the line in order to apply the exact quantity of the enamel to avoid a possible defects into the surface of the flat wire. The enamel type and the number of passages are a decision that is made together with the R&D department with their study through the viscosity and the tangent delta application. We can also reach up to 150 microns of the varnish per side in order to guarantee the request for our customer for the best e-mobility solution. After enameling part, we go into the inline blister and pinhole detector. Is 100% controlled inline in order to guarantee the best quality of the flat wire. This guarantee a flat wire with a high quality level in their performance.
This is our technical department where all the production starts and where the customer requirements are translated into actionable production instructions, and where we deeply analyze the feasibility of every process, and where we study the possible solution to avoid production problem, and where we made some researches about our product to develop a new solution and to propose alternative solution to customers' requirements. So here we work strictly and closely to the other departments, with the sales, where the information needed for the production comes, and with the production and with the reviewing department to be sure that every product that we produce is of high quality and that satisfy customer requirements.
We are in our laboratory dedicated to advanced material analysis. Here we can go beyond standard quality control and we can perform deep characterization of every material we produce. Using our digital microscope, we can provide bidimensional and three-dimensional measurements. We can check our enamel distribution and homogeneity, and we can perform advanced 3D imaging for a structural and comprehensive surface of our product. Moving to material structure, we use DMA, DSC and TGA. These advanced tools allow us to study the mechanical and thermal behavior of our products. We can analyze glass transition temperatures, thermal stability, curing state, degree of crystallinity, in order to guarantee the material properties over time. To complete our material analysis, we use the FTR to verify the chemical fingerprint of every polymer. Here we can analyze the molecular structure and we can verify the curing state and the purity of our material. With this module, we can also provide gas analysis of the emission of our products. And finally, we reach the core of our automotive validation. Here we can perform partial discharge testing in order to verify our insulation limits and the presence of defects in our enamel. Coupled with this, we can conduct voltage endurance tests, up to 6 samples in parallel using pulse signals. This allows us to simulate real inverter conditions in air and in oil, reaching temperatures up to 220 degrees. From chemical analysis to electrical testing, we are able to provide the complete characterization to drive the future of automotive.